Welcome to anyone tuning in to video 1 of our Cyclic Motions unit for IB Physics HL. In this video, we'll be going over 3 questions that help apply knowledge to exam-style questions. Now, without further ado, let's begin with the first question. Question 1. A load is suspended on a spring, storing a potential energy of EP. The changed system uses the same spring and one load. What is the total potential energy stored in the changed system? In part A, the original spring is split into two, where both the springs suspend the same load. This would mean that Kx, where K is the spring constant and x is the extension, would be equal to 2 times K1 x1. However, since we know that the spring used will be the same, the spring constant is also the same. This will get us the equation x1 is equal to x over 2. Using our x1 value, we'll find the elastic potential energy in the new system, EP1. This is equal to half k times x over 2 squared times 2. This simplifies into half k times x squared over 2, which can also be rewritten as half EP. Therefore, the new elastic potential energy in the system will be the original elastic potential energy EP over 2. In part B, the original spring is used twice to suspend the load. Using the laws of conservation of energy, the force acting on the original spring should equal the total force acting on both springs in the new system. Therefore, we get the equation F equals 2 times half F prime. Force in this case is Kx, giving us the equation Kx is equal to Kx prime, where the extension in the new system is equal to the extension in the original. Substituting our new extension 2x in the elastic potential formula, EP prime will be 2 times kx squared. Since we want to know the elastic potential energy in the new system in terms of the original, kx squared can be substituted as 2EP. Therefore, the new elastic potential energy will be 4EP. Question 2. A block of mass 10 kilograms rests on a trolley of mass 40 kilograms. The coefficient of friction between the block and the trolley, U, is 0.5. A horizontal force, F equals 5 newtons, acts on the block. The block slides over the trolley. What is the acceleration of the trolley? First, we need to consider both the block and the trolley as two separate objects. So we'll draw free body diagrams for both. For the block, there will be a weight of mg and a normal reaction force acting in the vertical directions. To the right, there will be a horizontal force, 5 newtons given to us in the question, and an opposite force acting to the left as friction. As for the trolley, there will be a weight mg and a normal reaction force, as well as a frictional force only acting to the right. Using these two free body diagrams, we can find the force acting on the trolley is equal to the frictional force on the block. Therefore, the force of friction will be equal to the weight of the block times the coefficient of friction given to us. This can be rewritten as mu times mg, or 0.5 times 1 times 9.81. Notice the mass is equal to 1, since both the object and trolley can be divided by 10 kilograms. This will get us a total frictional force of 4.91 newtons. Using our understanding of force acting on the trolley is equal to the frictional force we just found, we can simply do F equals ma, where a is rewritten as F over m, and find acceleration of the trolley. In this case, acceleration will be 4.91 over 4. Therefore, the acceleration is 1.23 meters per second squared. Question 3. A car is turning around a corner of an open space. Part A. Identify the force acting on the car. To do this, we'll just be drawing a free body diagram. There will be mg acting downwards and a normal reaction force to that weight. Since the car is turning around a corner, there should be a frictional force acting towards the center of rotation, which will be the only force acting on the car. Part B. The car is traveling 165 meters from the center of rotation. The coefficient of friction is 0.8. Find the maximum speed of the car given that it continues to travel in circular motion. Since we are trying to find the maximum speed of the car traveling in circular motion, the frictional forces acting on the car should be equal to the centripetal force. Therefore, mg times mu is equal to mv squared over r. If we isolate velocity, we can get v squared is equal to rg mu, or v is equal to square root of rg mu. Since we know the values of r, g, and mu, we can rewrite this as the square root of 165 times 9.81 times 0.8 is equal to the velocity. Therefore, velocity will be 36 meters per second. And there we have it, 3 exam-style questions on cyclic motion. If you found this video helpful, please feel free to see some of our other content explaining IB math or physics through our channel. Thank you for watching, and we'll see you next time.